On behalf of the design and prototyping prosthetic finger using PETG plastic and 3D printing technology, I would like to welcome you today. For those who don't know us yet, our web member consists of Piradon Ankalongnak, Palawat Papansi, and me, Purin Dantimala. We are from Surat Vivat School, Thailand. Our presentation will focus on five main topics. First is introduction, objective, methodology, result, and the last one is conclusion. First of all, let's commence with our intro. Fingers are one of the most important organs that we use in daily life. We use it for holding, scratching, snapping, and much more. Many people have lost their finger because of some cerebral accidents or congenital disabilities. In the present, there are only few cases of prosthetic finger developing ineffectiveness. These fingers are built that this are adapted to the size to each person, so it can be worn only individually and can't move like real human finger. Therefore, we create and develop prosthetic finger that have high efficiency, strength, and consume low expenses. And the important thing is it can move like real human finger smoothly with the use of 3D printing technology. Furthermore, let me explain more about finger anatomy. There are three joints that are relevant to our project. First is distal interphalangeal joint or DAP. Second is proximal interphalangeal joint or PIP, and the last one is metacarpal joint or MCP. Now, I would like to move on to the next topic is objective. First is to study the prosthetic finger and 3D printing technology mechanism and to create the movable prosthetic finger that consists of efficiency, strength, and also can have low expenses. Now, next, I would like to move to the next part, which is our methodology.
Our methodology has four steps. First is the study, second design the model, third print the model in the 3D printer, fourth test and find the problem, then improve and reprint it. The first step is to study the anatomy of human finger, and we also study the material that we use in 3D printer. The second step is model design. We design the model through Autodesk Fusion 360 program. We separate our prosthetic finger into five major parts: distal phalanx, middle phalanx, proximal phalanx, DIP, and PIP. The patient can put the rest of their finger into the proximal phalanx of the prosthetic finger. Our design Our design uses synthetic ligament attached to the model body to replace the tendon in human finger. There are two kinds of the synthetic ligament that we use, consist of flexible and inflexible. In the image, an inflexible green ligament is placed below, and a flexible black ligament is installed on the upper side. We also cover the surface with the silicone to increase the friction. At printing step, you can save the model that you design in Autodesk Fusion 360 as STL or 3D file, then slide the 3D file into layer through the program Articular Maker to prepare for printing. After that, save this slide file and print it in a 3D printer. The material that we use for printing is polyethylene terephthalate glycol or PETG plastic. PETG plastic is a material developed from polyethylene terephthalate or PET that is used in the production of water bottle that we use in daily life by adding glycol to make it clearer and more sticky.
This image show when we finish our printing process and connect all parts together. In the testing process, we start with a flexion and extension test. Image 5 and 6 reveals that when we press our finger down, the prosthetic finger will bend because the green tendon is tight. Therefore, DAP and PAP will move down, and black flexible tendon will stretch. But when we move our finger up, the black flexible tendon will shrink, so it will pull DAP and PAP back. As a result, the prosthetic finger can actually work, and amputees can control the flexion and the extension of the prosthetic finger in every joint easily, and they can use the prosthetic finger to hold or grab an object. At a first glance, Table 1 reveals that both DAP and PAP can be bent up to 95.26 degrees and 78.14 degrees respectively, which are the maximum, and the minimum of both angle is 0 degrees if the prosthetic finger is stretched back. On the other hand, the average angle can be calculated when the finger in use by the amputee or taster, and we measure it for 5 times, that's shown in table 2. As you can see, the average of bend angle of PAP joint is 76.64 degrees, and average bend angle of DAP joint is 70.31 degrees. The next process is strength test. The strength of DAP and PAP joints can be tested by hanging a pendulum in 5 different weights, from 1 to 5 kilograms, on the fingertip of a prosthetic finger, which the results are shown in table 3. DAP joint can receive the weight up to 4 kilograms, whereas PAP joint can receive 3 kilograms and break on 5 kilograms. The expenses that we have spent for the material was 230 baht each.
To conclude, from the experimental results, it can be seen that our prosthetic finger can be used in daily life. It can pick up the object with a natural gesture, the same as real human finger. It has low cost, strong safety, and can encourage disabled persons to obtain a better life. But there is also a flaw in design that makes it difficult to use, and the surface is still hard. In the future, we plan to create and develop prosthetic finger that can be able to adjust the size of every person and add some material for comfort. We believe that if we continue to develop our prosthetic finger in this project, we can create the model that completely replace real human finger and has affordable price to help every disabled person to obtain a bright future. I would like to thank you for your time and attention today.